Okay, so like I said, there will be a little blue box that shows up. I wasn't able to catch it with my recording, but it's a blue box and there should be like a little green check mark that says slope, and that lets you know that ArcMaps is done processing that function. And so on my computer, that took about just under 5 minutes for it to go through. So again, like I said, be patient, and then ArcMap will automatically load your slope layer to the map that you can see here, and it'll display in your layers. And so the way that this color scheme has it going, the greens are your lowest slope, and then your reds are your steepest slope here. And you could go ahead when you're in lab and open up those properties and kind of experiment with the different color schemes that you can get with it. Okay, so aspect identifies the downslope direction of the maximum rate of change in value from each cell to its neighbors. It can be thought of as the slope direction. The values of each cell in the output raster indicate the compass direction that the surface faces at that location. It is measured clockwise in degrees from 0 or due north to 360. Again, due north. That's a coming full circle. Flat areas have no downslope direction and are given a value of -1. The value of each cell in an aspect dataset indicates the direction of the cell's slope faces. Okay, so now I'm going to do a demo on how to create an aspect layer. So again, I have my Arcata North-South DEM, and I have my Arc toolbox open, and again, I'm going to navigate to my Spatial Analyst toolbox. I'm going to go to Surface, and this time I'm going to click the Aspect function. Okay, so for whatever reason, the longer I have ArcMap open, the quicker these windows open up, so that's great. So I have my input raster again of Arcata North-South, and I am going to make sure that I'm putting my output raster into that working folder, and again I have my lab demo separate from my the first working folder that I made, just to make it more clear on your guys' end. So I'm going to call this layer Aspect, and I'm going to click Save. And this is a pretty easy process. I don't need to fill anything else out. And I'm just going to select OK. And so here I've got my little globe going, and it's letting me know that it is processing that aspect layer, and we're just going to give it a second to process. All right, and there is our little blue box that I was telling you about with slope. And now I know that my aspect was successful. And I could also tell because of the aspect layer that has now been created by ArcMap and included to my map data layers. And I just think that these are really beautiful. Again, you can experiment with the different color schemes and see what works best for whichever type of data that you are needing to display. And again, if I were to remove that, my DEM layer is underneath, and I could turn that on and off and also remove it if I need to. Okay, so here we have a hillshade, also known as a shaded relief map, and this is a depiction of the brightness of terrain reflections given a terrain surface and sun location. Although shaded relief maps are rarely used in analyses, they are among the most effective ways to communicate shape and structure of terrain features. and many maps include relief shading. So relief shading is often added as a background under other mapped data to provide a sense of terrain shape and steepness. This shading provides a three-dimensional perspective for a mapped area, as we can see here in this image. You simply apply a transparency to both the hillshade layer and whichever themed layer you choose to overlay over the top of the hillshade. Okay, so this is going to be a quick demo on how to create that hillshade. So again, I'm in my Spatial Analyst tools, I'm in Surface, and here I'm going to select my hillshade function. And my input raster is going to be that Arcata north-south again. And of course, I'm going to make my output my working folder, and I'm going to name it Hillshade. And something that I didn't really touch on, but we'll definitely go over in the lab instructions, but you know, in general with ArcMap and ArcGIS, you can't put any spaces in your titles, and this is especially important for raster files. Okay, so now that I have my output set, I'm going to keep all of the other settings at defaults, and I'm going to go ahead and click OK. And again, I have my little world going down here letting me know that the hillshade is being created. And so I'm just going to give ArcMap a second to do this. And once it's done, I'm going to go over how to create a transparency. Oh. Okay, so there is my little box letting me know that it's ready, and here is my hillshade layer. So I am going to now turn on the salamander conservation layer, which you'll be working with. I'm going to go ahead and just zoom in on this area. Okay, so the first thing that I want to do is create a transparency for my hillshade. So I'm going to open up the hillshade properties. And it brings you right up to that display tab, and here is my transparency box. And so I'm going to start at 50%, and I'm going to click apply, and I'm going to see what that looks like. And that is quite a bit of a difference. I'm going to see what it looks like at 60%. I'm going to go up a little bit higher. Let's see. Okay. I'm going to go back down. Okay, so that's a little bit more how I want it to look. So then I'm going to also apply a transparency to my salamander conservation boundary layer. And so by doing that, you're going to allow that shaded relief to shine through your top layer. So again, go to display, and here I have my transparency. So I'm going to start at 50% and see what that looks like. And so I might just add a little bit more. Okay, so that looks pretty good, and you can see that hillshade relief underneath. I'm actually going to make this a little bit darker. Let's see what it looks like at 50 again. And 60. Okay, so that looks pretty good. Okay. So the last function that we're going to go over today is how to create a viewshed. The viewshed for a point is the collection of areas visible from that point. Views from many locations are blocked by terrain. Elevations will hide points if the elevations are higher than the line of sight between the viewing point and the target point. Viewsheds and visibility analyses are important in many instances. High voltage power lines or cell towers are often placed after careful consideration of their visibility, because most people are averse to seeing them. A view shed is calculated based on cell-to-cell intervisibility. A line of sight is drawn between the view cell and a potential visible target cell. The elevation of this line of sight is calculated for every intervening cell. If the slope to a target cell is less than the slope to a cell closer to the viewpoint along the line of sight, the target cell is not visible from the viewpoint. Specialized algorithms have been developed to substantially reduce the time required to calculate view sheds, but in concept, lines of sight are drawn from each viewpoint to each cell in the digital elevation data. If there is no intervening terrain, the cell is classified as visible. This classification identifies areas that are visible and hidden. Okay, so now I'm going to show you how to create a view shed in ArcMap. So I'm going to be in that surface toolbox within my spatial analysis tools. And so I'm going to click the view shed box. And so my input raster is going to be that Arcata north-south. And then my input point is my observer point, which I got from the Lab 10 original data. And again, I'm going to make sure that my output is going into my working folder. Okay, and I'm going to leave all the other settings the same. So you can see this is where my observer point is, so pretty much any terrain that's going to be visible from this point will be displayed in my view shed layer, which we can see our little world spinning down here, and that view shed is being processed. And we'll just give it a second. There it goes. And I got my little box to let me know that it's clear. So over here in my layers, I can now see that in my view shed, everything in pink is not visible, and everything in that light green is visible from my observer point. And I'm going to add a quick transparency so we could get that really nice shaded relief from the hill shade underneath. So I'm going to set that transparency to just about 60. Whoops, did I open up the hill shade? I meant to open up my view shed. Let's see. All right. And we'll just hit OK. And you get that really nice shaded relief. And we can see here that, again, everything that is in green is going to be visible, and everything that is in pink, which we could see from our hill shade is higher elevations, is not visible. Okay, so that wraps up this portion of the lecture. I will upload the second half of the lecture on Thursday, April 28th at the beginning of class.